Nelson Mandela, said that everyone can rise above their circumstances and achieve success if they are dedicated to and passionate about what they do. Assalamu alaikum, dear students, this is Ms. Sada Bahar, your physics teacher. I hope you all are fine. Well, dear, in our previous lecture we explained characteristics of sound, a topic of Unit 11. Now to step ahead, today we'll do some topics of the same Unit 11. These topics are mentioned on the first slide of the presentation. So before taking proper start of the lecture, first of all, learning objectives of the lesson. Learning objectives. At the end of the lesson, students should be able to explain reflection of sound, know the effect of the medium on the speed of sound, know how to find speed of sound by echo method, describe that noise is nuisance, list the importance of acoustic protection, describe the audible frequency range for human. Reflection, echo, of sound, exercise, question, 11.14, answer, definition, when sound is incident on the surface of a medium it bounces back into the first medium. This phenomenon is called echo, or reflection of sound. Explanation, the sensation of sound persists in our brain for about 0.1 seconds. To hear a clear echo, the time interval between our sound and the reflected sound must be at least 0.1 seconds. If we consider speed of sound to be 340 meter per second at a normal temperature in air, we will hear the echo after 0.1 seconds. The total distance covered by the sound from the point of generation to the reflecting surface and back should be at least 340 meter per second into 0.1 seconds is equal to 34.0 meter. Thus, for hearing distinct echoes, the minimum distance of the obstacle from the source of sound must be half of this distance, that is, 17 meter. Question. Explain with the help of an activity reflection of sound. Answer. Activity. Take two identical plastic pipes of suitable length, as shown in figure. We can make the pipes using chart paper. Arrange the pipes on a table near a wall. Place a clock near the open end of one of the pipes, and try to hear the sound of the clock through the other pipe. Adjust the position of the pipes so that you can hear the sound of the clock clearly. Now, measure the angles of incidence and reflection. We found both are equal, that is, angle I is equal to angle R. Lift the pipe on the right vertically to a small height, and we will observe that the sound will start becoming fainter and finally, no sound will be heard at some height. Speed of sound. Question. 11.2. Answer. Sound waves can be transmitted by any medium containing particles that can vibrate. They cannot pass through vacuum. However, the nature of the medium will affect the speed of sound waves. In general, the speed of sound in a liquid is 5 times that in gases, while the speed of sound in solid is about 15 times that in gases. This shows the speed of sound in solids and liquids is faster than in air. The speed of sound in air is also affected by changes in some physical conditions such as temperature, pressure, and humidity, etc. For example, the speed of sound in air is 343 meter per second at 1 atmosphere of pressure and room temperature 21 degrees Celsius. This speed varies with temperature and humidity. Following relation can be used to find the speed of sound. V is equal to F lambda. Here, V is speed of sound, F is frequency of sound waves, and lambda is wavelength. Measuring the speed of sound by echo method. Answer. Apparatus. measuring tape, stopwatch, flat wall that can produce a good echo. Procedure 1. Use the tape to measure a distance of 50 meters from the wall. 2. Now clap your hands in front of the wall at a distance of 50 meters and check if you can clearly hear an echo from the wall. Make sure the echo is not coming from any other wall in the area. The time taken by the sound to travel 100 meters is the time difference between the clap and the echo. 3. Now restart the clapping and start the stopwatch at the first clap. Count the number of claps, and stop the clapping and the stopwatch when you hear the echo of the 10th clap, say 4. Now find the average time for 10 claps. After calculating the time interval between claps and using the formula, S equals Vt, we can calculate the speed of the sound. Factors which can affect the accuracy of this method. Dear students, all the factors are listed on the slide, read and understand it. Noise pollution. Question 11.16. Answer: musical sound. Such sounds, which are pleasant to our ears, are called musical sounds. Example: sound produced by musical instruments such as flute, harmonium, violin, drum, etc. Noise: some sounds produce unpleasant effects on our ears. Such sound is called noise. Example: sound of machinery, the slamming of a door, and sounds of traffic in big cities. Noise is a nuisance. Noise corresponds to irregular and sudden vibrations produced by some sounds. Noise pollution has become a major issue of concern in big cities. Noise is an undesirable sound that is harmful for health of human and other species. Transportation equipment and heavy machinery are the main sources of noise pollution. For example, noise of machinery in industrial areas, loud vehicle horns, hooters and alarms. Noise has negative effects on human health as it can cause conditions such as hearing loss, sleep disturbances, aggression, hypertension, high stress levels, etc. Question 11.17. Describe the importance of acoustic protection. Answer: acoustic protection, the technique, or method used to absorb undesirable sounds by soft and porous surfaces is called acoustic protection. Importance of acoustic protection. Reflection of sound is more prominent if the surface is rigid and smooth, and less if the surface is soft and irregular. Soft, porous materials, such as draperies and rugs, absorb large amount of sound energy, and thus quiet echoes and softening noises. Thus, by using such material in noisy places, we can reduce the level of noise pollution. However, if the surface of classrooms or public halls are too absorbent, the sound level may be low for the audience. It is often advantageous to place reflective surfaces behind the stage to direct sound to the audience. Generally, the ceilings of lecture halls, conference halls, and theater halls are curved, so that sound after reflection may reach all the corners of the hall. Question 11.15. What is the audible frequency range for human ear? Does this range vary with the age of people? Explain. Answer: audible frequency range for human ear. A normal human ear can hear a sound only if its frequency lies between 20 Hz and 20,000 Hz. The range of the frequencies which a human ear can hear is called the audible frequency range. Different people have different range of audibility. It also decreases with age. Young children can hear sounds of 20,000 Hz, but old people cannot hear sounds even above 15,000 Hz. Infrasonic, the frequency of vibrating body below 20 Hz is not audible to human ear, and is called infrasonic. Ultrasonic, or ultrasound, the frequency of vibrating body above 20,000 Hz is not audible to human ear, and is called ultrasonic, or ultrasound. They are high, energetic waves. Well, dear students, I would end with a quote of Nelson Mandela: "It always seems impossible until it's done." Okay dear, stay safe, thanks.